Welcome, everyone. Thank you so much for coming and sharing your time to listen. I guess before I start, I wanted to offer an apology. Kerry Lyon, my partner, couldn't make it, so at a kind of drop of a hat, I've joined in and will do my very best to present in Kerry's stead. Him and I worked on the project, but he was the director in charge. So I think I want to acknowledge, obviously, Murdoch University. They were a critical agent in this. Clearly, they wanted to change the way their campus was working. They wanted to demonstrate, kind of a fairly serious commitment to obviously progressive education, but also to environmental awareness. And also I want to acknowledge our partners in collaboration on the project. Silver Thomas Hanley, Perth-based practice, Fulcrum Agency, Perth-based practice, Officer Wood, Perth-based practice, and Aspect Studios, again, Perth-based practice. We couldn't have done this project without them. They each had a part of it, but they also engaged very much in the intellectual discussion as we were forming the project from a master plan point of view. So again, thanks to them, and obviously acknowledging the commitment of Oricon as engineers in the project to, not only engaging in the kind of conceptual ideas of the project, but also deep commitment to the technological resolution of that, which you'll obviously see as we move through the project. Boola Katitjin, deep knowledge, much learning. Obviously, was a project that I'm just trying to now progress the slides. Locates the building very much on Wajak Noongar country, but also on a kind of a semi-rural campus on the edge of Perth to the south, in what was a very heavy 1970s style campus, designed primarily and master planned by Gus Ferguson. We were taken by how beautiful the campus was in many ways, around its structure and the bush nature of the campus, but also we were taken by how, in some ways, it was very resistant to contemporary modes of learning, which I'll talk to a little bit further on in the presentation. Boola Katitjin was a major insertion into the campus. It obviously had to accommodate a significant amount of teaching and learning space and become a nexus for all the students on the campus, but at the same time it had to connect from the major entry to the south on Discovery Way up to Bush Court, which is effectively the kind of, in some ways, the heart of the campus, past Banksia Court. So not only did the building have to kind of, I guess, provide lots of space for students and academics, it also had to perform a very strong urban design piece on the campus as a connector, both to the environment and to the adjacent buildings. It's obviously a very large insertion relative to the other buildings, but it's also in some ways acknowledging those buildings. I guess from the very inception, the university was keen on demonstrating a commitment to the environment, not only in the sense that the building is highly connected visually to the environment. A lot of the educational spaces, peer learning spaces are outdoors in this building, obviously large areas of shaded glass. But they also wanted to innovate in timber construction, and obviously the design team was very happy to come on that journey with them and drive a great outcome for the university. Very large span teaching spaces, obviously in that sense that we wanted to have timber both indoors and outdoors. Obviously there's a substructural concrete base coming out of the ground, but then the timber from the very lowest part on the south all the way up to the outdoors had a mixture of both internal timber elements, which were spruce was sourced from Italy, dolomites, Hess, and then external timber that was either protected or exposed, which we had to then treat, and that's obviously Australian timber, hardwoods sourced from Victoria sustainably through stewardship programs. And as you can see, the building, as it came up, variously had a combination of these different products, depending on whether it was indoors or outdoors, until we arrive at, obviously, a very large superstructural roof element, in keeping in some ways with the campus, but very much skewed and asymmetrically deployed to provide greater shade to the open areas to the west and shedding rain solar panel farms on the roof, etc. So as you can see in this kind of aerial view, looking back at the building, it sits on kind of in some ways concrete feet. In some ways we thought about them as anti-termite mounds, and then the timber obviously ran it from there. Lots of sun shading, but wherever we found possible, we tried to bring the timber out to make it visible clearly inside, but out externally treated to obviously withstand the weather. And getting that balance between what was cladded and what was open was really important in terms of making sure that the building will last for a long time. You can see in this view the roof is also constructed from CLT, which spans between the main roof beams and to the west that large urban colonnade that runs in from the bus stops and the drop off on Discovery Way all the way up through the campus, where you can either choose to remain under the eaves but outside of the line of the building, or come into the building and traverse the length of it without going inside, but well undercover through the informal learning spaces, which you'll see as we go further. Concrete kept at very much the ground level, raw on the show, but as we progress up through the building, the timber then stacks in a modular, systemic way wherever possible. But of course, we also look to break the system where we think it's important to bring outdoor learning spaces to over the top of the large urban colonnade. And lifts as we go up. Importantly, also, you can see that we've made connections laterally through the building on every level, which I'll talk to in a minute. But at ground level, we are making the building, given its length, a very porous building from Banksia Court across to the veterinarian buildings on the far side. As I mentioned, a lot of the outdoor learning spaces connected to indoor learning look back towards Banksia Court, giving a sense of deep connection. But also a sense of how it knits into the campus, creating a clear sense of, student promenade through from Discovery Way to the upper level of the campus. And you can see this image. There is a destination space, which we in the video talk to a large meeting and gathering space adjacent to a large remnant gum tree that was retained through the project. I mentioned Gus Ferguson's work. We find it, very strong architectural work, which we enjoyed, and we felt that it was important that in some ways we riffed on the sense of the campus, not to throw it out, but to take some of the systemic language of Gus's, but to reinterpret it very much in a new, lighter timber form. And as you can see, as you come out of the large bush court, Boola Katitjin is a very large and welcome opening to the north around that gum tree. So a very large space. I'll leave Oricon, Ralph, to talk to the complexities of the structure in this area, but it's a really important gathering space. Again, as you can see here, Oricon very committed to testing this structure within an inch of its life to make sure that it could withstand the rigors of lateral loading, given the shape of the structure as a portal frame. But it also importantly serves as a large cultural gathering space. This is the opening of the building, the smoking ceremony within the large eaves of the gathering space. And then looking back at the building where the digital screen obviously forms a front drop to what effectively is a large, deep, but very transparent, open and welcoming student environment. This is the space that was designed by Officer Wood, the very front of the building, student services area, which you can see here. And this is the start of a long street that runs all the way through the building and connects all of the formal learning spaces through an informal learning hall. Again, you can see here a engagement space for students and staff, and more informal learning spaces, engagement on the upper levels. Maybe to talk about the educational program. So as you can see, the linear orthogonal nature of the Gus Ferguson master plan, very long, thin buildings with double-loaded corridors, and the dark green effectively showing the flat floor teaching space, which are smaller format, let's call them tutorial rooms, and larger lecture theatres. And clearly, as you can see, that's a sort of, in some ways, there's an element missing under contemporary scale teaching, which is the ability for large groups of students to break into smaller groups and collaborate. Where, for instance, that's the whole of the teaching cohort range within the campus. Before we started the project, our aim was to try to open up that middle ground where we had large format tiered and flat floor space that allows students to have didactic delivery, and then to move to informal learning in groups. And then obviously the corollary of that is that they then have large areas of indoor and outdoor breakout space to connect into. So that basically significantly increased the teaching space for the university. And whilst it obviously still requires tutorial space and other learning that's closer in the academies, here we have a large general purpose teaching destination area on the campus. And they range from 60 strong to 120 strong, with 90 being in the middle, and a whole range of different contemporary educational styles that are structured within that timber, large span timber portal frame post and beam structure. In plan, if you imagine this is kind of up on the upper level where the meeting space of Boola Katitjin on the north is. You can see I mentioned that large corridor that runs through and then arrives at a large informal learning hall in the middle of the building, which then has double loaded corridors. So in some ways, it's a very, very large scale version of Gus Ferguson's plan, but we've stretched the corridors much wider to create a large informal learning environment in the middle, and then obviously scaled up all of the teaching space on either side. And at the very south end of the building, we then also have a destination space for staff. Again, no designated faculties. This is actually a space for all staff to go and work in when they're engaged in teaching activities or afterwards. And I also mentioned again, so if you can see here, the large spans, 11 metre spans for the timber, 8 metres through the middle and 6 metres in the other direction. Again, very systemic and modular. But that still provides very large, 170, 180 square metre spaces for collaborative learning, technology enabled learning, or TEL, and experimental learning throughout the building. And then importantly, in our view, cutting through the grain of the building, we then have large open breezeways that do connect to the outside, which have circulation nodes out to the east, views to the west, and obviously it gives opportunity for wait and pause as you're walking along the length of the informal learning through the student halls and then into the classrooms. And quite differently, as you imagine, rather than having entrance into the classroom spaces from the student hall, we inverted it and brought them off of those throughways as a way of making the student hall not feel like it's continually space that has students moving through it, coming in and out of class and waiting to go into class. So I guess the waiting space is flipped to the lateral spaces. A key part of the design activity, which we worked very closely with Oricon all the way through, was to think how we could deliver the engineering services through the building. We've got a UFOD system, underfloor distribution of air, and also obviously bringing some of the other cabling through the floor. But obviously the benefit of UFAD, or low velocity air conditioning, is that it delivers the air slightly warmer temperature that you need it if you're blowing it back down through all the hot air to the students and teachers at the lower level, which is important when you're talking about high floor to floors, which we have in this building to take advantage of the benefits of the timber. And then, of course, we then have very well designed. We put a lot of effort into designing the catenary systems on the soffit, along with acoustic paneling, with electrical risers running up through the walls from the cavities. Again, much of this was done through a very detailed shop drawing process. So you can see here, for instance, all of the services, significant fire, dry fire penetration, electrical pens and comms had to be all pre-designed through the timber, so that anything, when it all came on site, it was all prefabricated, sped up the construction process significantly, obviously made it much simpler, and you get a very neat effect. So that was a really important part of the design, was to get all of that done through the design phase and not lead it up to site. It's It's worth pausing at that to mention Multiplex, who are obviously an incredibly key component to this project. They did a lot of work and research to make sure this building came together well. And whilst we all would talk about the biophilic benefits of working in a very lovely building that's got structure on show, the smell's different, even Multiplex said that constructing this, once we got past the concrete trades, was an absolute joy because the site was much cleaner, things came together much more quickly. And I guess if you think about the labour force, 400, 500 people that work on these buildings for 2 years, the fact that they're enjoying their labour more, their construction, I think is, important as much as it is for the legacy of the students and teachers in the future, enjoying the benefits of the timber structure throughout. So again, you can sort of see these classrooms with the UFED floor vents coming up through, very little services running through the ceilings, but where it does, it's all been highly coordinated prior to construction. This is the student hall that runs between the classrooms. So whilst there's lots of visual interconnection from this space, you don't actually enter into the classrooms on either side or the teaching spaces. And I guess we designed this so that it works for all facets of the year when, earlier on in the semester, students are working, collaborating together, and as they then transition into the later part, they can then undertake individual study on these areas. Again, this is one of the lateral breezeways that runs through the building out to the facade. So when you're crossing through, there's obviously lots of opportunities for relaxation. Again, the coating of the timber talks to outdoor, indoor, natural ventilation. Kitchens are located in here with openable louvers, so we can get mixed mode ventilation. And then finally, those break out in the sort of Banksia pod idea of these pop outs through the facade to bring you out over the walkway that runs up and down north-south through the site and looks out over Banksia. The Banksia Gardens is really critical. Looking back, as you can see, connecting those outdoor spaces with escalators to drive engagement in them is important. And then on the very uppermost level, where we're under the super eaves, again, indoor-outdoor space, very blurry, encouraging students to use both of them in all weather. It's critical to the design. So this is stepping back inside the upper level informal learning spaces. Sorry, my apologies. There we go. And now we're back in one of the large format teaching spaces. It's a tiered space. Obviously anyone can access it at every level. There's ramps into all of these rooms, ease of access, but also digital technology was critical. So as you can see, large format screens to assist in teaching, and each table also has collaborative screens so students can work on group projects and then reproject to the large screen and share it with a wider class. And then beautiful feature spaces for holding conferences, events, teacher education, etc. is really critical. One of the large feature spaces to the south and the very upper level of the building, again with the timber structure bracing on show. Wherever possible, we've tried to keep the timber true to its structure. And then finally, looking down on the roof with a large solar farm. It's important. So I hope I haven't gone too quickly through that. I'm happy to answer questions, but around some of the performance metrics, obviously mass engineered timber used in 64% of the structure. Suffice to say, when you're there, you don't get a sense of the concrete so much. The timber really is the dominant material. The building achieves 6-star Green Star Design certification, which is world's best practice. 55% reduction in embodied carbon when compared to an equivalent concrete building. Again, I'm sure Ralph will talk in more detail to that. 90% reduction in operational energy when compared to a reference building. And there'll be a whole range of factors for why that happened. Obviously, high performance facades, underfloor air conditioning systems, reducing fan speed, and obviously solar energy being put back into the grid. But I guess the thing that I wanted to pause on, which I intimated in the video, the BBC, was the sense of what the building does, I think, in terms of that idea of a circular economy. And whilst the engineers would have it as a four-part circular economy, I guess we'd like to talk about the economy of air. And we think that a really important plank to sustainability is the idea that a building has a durability where people love it and that they care for it. And that is a really important aspect. I mean, clearly it needs to be resilient and withstand the change that will occur through education over the next 50, 100, 200 years. But I think a good starting point beyond just large spans and flexible floor plates is that the building is something that is thoroughly loved. And I think whilst we haven't done deep post-occupancy evaluations and surveys, much of the feedback that we're getting around the benefits of biophilic design is that it is a much loved building for both staff and students. It's a significant destination, helped I think a little bit by its ability to connect the campus from its entry to the Bush Court. But nonetheless, we are convinced by the feedback we're getting that the sense of working and learning in a building that obviously demonstrates not just a commitment to an environment but feels like it's part of the place is an important part of that idea of sustainability beyond just metrics and what are the metrics of people enjoying, loving and caring for buildings and architecture, I think should be brought into the equation somehow. So that's me done.
Awesome. Thanks, Neil. Good morning, everybody. Pleasure to be here to present our journey on Boola Katitjin for you. Before I started, I just wanted to touch on something that Neil spoke about. The one thing that really strikes me about this building and comments that people have made, and I'll just reinforce to those of you on the call that are not WA based, if you ever go to Perth, it's a public building. If the university is open, you're welcome to go there and walk through it. And to a person, everybody that visits site says that the photos don't do this building justice. So it's an amazing building, and the way that it makes you feel is kind of next level. And I'm kind of biased as the person that kind of set the structural scheme in the initial thinking of the project. I thought I was super biased, but now I'm hearing it from other people. I think it is a lovely building, and if you're ever in Perth, please do go and have a look at it. The other thing which is not lost on me is that the architecture of the campus, this really does tip the hat beautifully to the original architecture of the campus, which has a lot of off-form concrete in which you can see the grain of the form boards that were used, and it just seems to be a lovely, more sustainable representation of the same sort of architectural language. I've got to be careful as an engineer if I start talking about architecture. Neil might start yelling at me, so I might just leave it at that. But for me, it is a beautiful tip of the hat to what is already on campus. A little bit about me. I'm a structural engineer by training and timber capability leader here at Oricon. I'm in my 39th year here, and sometimes I have to pinch myself to think where the 39 years went. And my journey with timber started on day one, because my first job here at Oricon, predecessor company of Oricon, was designing 3 house frames a day using Australian Standard 1684 that I'm sure many of you will be familiar with, and then as a technical person moving on to the use of AS 1720. So I had the opportunity in the 90s, you can see top right there, to do some research. I actually built some glue laminated beams reinforced with carbon fibre and did that in Ozpine's plant in Portland, and then brought them back to UniSA in Adelaide while I was doing my undergraduate degree and snapped them and presented on the findings thereof. And that's been the one constant through my entire career, has been my involvement in timber projects, which has been really lovely. And to see a kind of a renaissance in timber is a lovely way as I sort of run towards the try line in my career, if I can use that analogy. In today's presentation, I wanted to touch on a few specific things. And again, Neil touched on this. We had a client with a vision. They really could foresee that they had a vision to build Western Australia's largest mass engineered timber building, and they were really driven to get that outcome. We needed a plan to deliver, so we had to work hard to work out what was possible within the constraints of a market that had never delivered anything of this size. It was important to lead by example, and I will show you some examples of that as we go through the presentation today. And I'll finish by talking in more detail about our robotics world first innovation at the end. So you've seen images of the building in Neil's presentation, so I won't dwell on this, but our journey with the project started in 2018, where I took a call from my Perth colleagues saying we have a client who wants to build a mass engineered timber building, and I attended a meeting in early December of 2018 with Kerry Lyon as well, and we were sat in a room thinking about what might be. We had recently moved into our Oricon office at 25 King Street in Brisbane, and you will notice that some of the language in this building is similar to the structural language of that building, and that's not by chance or a mistake. So we started talking about what might be possible, and just to give you a feel for the drive of the client, we mentioned that the only engineered wood product manufacturer in WA was Wespine, and that that was a local option for the supply of this building, and with the plant some 40 kilometres away from the site. The client was very interested in this, and he said, "Well, when can we get in to see the facility?" And I said, "Oh, look, I can make some calls and we can tee something up, maybe after Christmas." And he said, "Well, what about today? Can we see it today?" So I picked up the phone to Dr. David Byland, who many of you will know. Said, "David, I've got a client who wants to have a look at this facility." He said, "Yep, no, that's no problems." I said, "Can you get us in there today?" And 2 hours later, we were hard hats and high-vis vests walking around the Wespine manufacturing facility. So it just gives you a bit of a feel for the drive of the client to get the outcome that they were looking for. I really like this image because it shows the delineation between the concrete and the timber structures, and Neil touched on this earlier. One of the things that we worked hard to do in the early concept of the project was to make sure that the usages of the spaces were aligned to the materials that we were proposing. In Neil's images, I don't know if you picked it up, but there were some labs in the building, and from a serviceability perspective, we thought it was sensible to get those labs sat on the concrete elements of the structure, because one of the challenges we have with long span timber structures is controlling vibration and the serviceability issues that go with that. So we moved those spaces onto the traditional structure where we were using concrete to get out of the ground anyway, and deal with the durability and the termite separation issues that we would have to deal with anyway. I did see a question in the chat about lateral stability, and again, this image shows it pretty well. So the lateral stability of this building is dealt with a combination of concrete elements that you can see going up through the structure there, as well as the timber bracing, which is exposed where required. So in reality, you would kind of call this a hybrid in terms of its structural response. And Neil spoke about the embodied carbon reduction in a building like this, and the percentages that he quoted are kind of typical of a building like this, which is long and still has a reasonable amount of concrete in it to do the jobs that need to be done, like lifting the timber structure off the ground and dealing with the issues of lateral stability when you need them. You can see, as it's been discussed earlier, that the building was built from a combination of CLT and GLT. That once we started running the possibilities of it being an LVL structure to ground, we, in our discussions with Wespine, we knew that their facility was pretty much maxed out supplying the residential market, and that to turn their manufacturing facility to supply a project like this would not have been, good business for them in terms of the impact that would have had on their ability to supply the local market in their traditional sense. So I'll talk a little bit more about the processes that we went through to determine the capacity of the market to supply. This is an image which is almost very similar to an image that Neil showed of the finished building, but whilst the building was in construction, that shows the exposed elements of the structure while it was in construction. And yes, begrudgingly, we did let a little bit of steel creep in there as well, as you can see on the bottom right. So in order to find a way to deliver WA's largest mass engineered timber building, we thought it was appropriate that we pull the industry together to understand what the capability would be like to do that. So we hosted a timber forum in our Perth office in the middle of July in 2019, and we invited industry representatives, and most of the major players accepted and travelled to Perth to have this discussion about how we might unlock the supply chain challenges of undertaking a project like this in Western Australia. So out of that forum, we were able to determine what the possibilities were really for the supply of this building. And we did have a look at a number of different options in terms of the way that this building could be supplied. And you can see there our option one being the locally supplied option that I spoke to earlier. Obviously, from a sustainability point of view, it would have been lovely if we could have supplied the building from a very small footprint adjacent to the site. But it quickly became apparent that that wasn't possible. So then we were left to look at other options like supply out of Europe or from the eastern seaboard of Australia and potentially also from New Zealand. Interestingly, in terms of carbon footprint, what the analysis shows is that it was actually more carbon intensive to transport timber across the country on a diesel-powered truck than it is in a container ship from Europe to Perth, which might seem, in terms of the distance, might seem counterintuitive. But when you think about the volume of timber that you can fit on a truck and the amount of diesel that it would take to drag that across the country, compared to a container ship, which would have however many containers on it that it can hold and the amount of energy that it uses to sail across the seas, you can kind of reconcile in your own mind that it's not always what you would logically think in terms of the carbon footprint. I don't profess to be an expert in that, and I'm reliant on my colleagues who do those analyses. So I believe what they say. Here's an image of the building in construction. As Neil mentioned earlier, we used a number of suppliers, Xlam, Dolomiti and Hess out of Europe for glulam and CLT, respectively, and some Victorian ash hardwood out of Victoria for some of the elements where higher durability was required, and with the appropriate treatments depending on the exposure condition. And you can see the different colours of the material in this photo. It was very important that we had early contractor involvement in the project to understand how we would go about detailing the connections and making sure that the trades would be able to assemble the building, considering it was something new and different in the market that we were working in. So with Multiplex coming on board, we were able to source a number of elements and then build a prototype in the workshop so that they could get some familiarity with the detailing that was proposed and the ability to look at the various connection types. And further to that, again, as Neil mentioned earlier, the northern event space, which is a 30-metre spanning portal frame, which is probably my fault because at the concept stage, we were looking at options for that northern event space, and having been involved with a 40-metre span portal frame in the late 80s at Tumut in New South Wales, I thought, well, we should be able to do 30 metres easily. The big difference being that the one we did in 1988 was an industrial building, and it didn't matter what the connections looked like. But I don't think Neil was going to be too happy with very large plywood gussets attached to the moment connections, and then validating the fire performance of those would also be a bit of a challenge. So we did do a full-scale test on the most critical knee connection, and you can see my co-collaborators, Nikish on the left and Pratik on the right. And my gratitude to these two guys, absolutely, I need to reinforce that because, you know, I did the glory work at the front end establishing the concept, and these are the guys that did the hard work during the design and construction phases to bring this all together. So I tip my hat to these two guys, and you know, the efforts that they put in over the course of the project. So again, the northern event space in use, I think the great thing about photos like this is it gives some scale when you can see people standing in the event space, just to how huge this area is. And one of the big structural challenges in all of this, for those of you that are timber designers would know that we're always chasing serviceability criteria in timber structures. So having a clear span, 30-metre clear span space, and having it interface with the building, which is effectively propped at the apex, means that you have to be able to control deflection in the middle of the portal frame to a point where you don't read the difference between the two. So we did put a lot of work into working with the constraints that were placed before us to get an appropriate aesthetic outcome for that junction between the free spanning portal frame and then the glazed box that you can see back in the building there. And this is a view from the other side, again, showing that event space functioning, I believe, at the opening of the building. So again, as I mentioned earlier, we were lucky to have a very motivated and focused client who was also very keen for us to embed some innovation into the project. And when he said to us, we want to build some innovation into this project, we basically had carte blanche. So everything was on the table. At Oricon, we use design thinking methods. So we basically ran a ideation workshop with Murdoch University, University of Technology in Sydney. We also had RMIT there, where we put all the ideas on the table and then decided to hone in on something that we thought was achievable and doable within the time and the financial constraints. And we decided that we would attempt a proof of concept for robotic installation of the screws on this project. The reason for that is that it's a highly repetitive process, and what we're trying to do is we're trying to make timber construction more mainstream. So if we're able to automate the elements of timber construction which are rote and repetitive and bring health and safety issues with them, then we can help to break down the cost competitiveness scenario between timber construction and traditional construction types. So the first thing we had to do was choose a location in the building to do our trial, and this looked like a good spot. It wasn't lost on us that we chose a spot in the middle of the building just in case the robot decided to go rogue and drive itself towards the edge of the slab. We didn't want to lose $250,000 of robot off the edge of the building, so it seemed like a good idea. We could pull the plug before it got to the edge of the building, and we chose this strip. So effectively, the screws that we're talking about are 340 millimeters long. They're a Rothablas screw, and what we're automating is this process here. Now, I don't know about you, but if I was doing this job all day, every day for a number of weeks, installing those 300,000 screws, this doesn't look like a lot of fun to me. So this is the job that we're trying to automate. So we were conceptualizing this all through COVID. So we couldn't really collaborate in person. So a lot of the work was done over Teams. We provided our Revit models to University of Technology in Sydney as a digital twin, and effectively they built their software for the process in the virtual world. And this is a virtual representation of the robot installing the screws and then finding its way from location to location within the building. So once they were able to validate the software approach virtually, we then moved to a trial in the UTS labs in Sydney. The white box you can see on the right-hand side is representing the column in the building. So the robot uses a combination of GPS and LiDAR to locate itself, and then referencing back to our Revit model can locate the individual screw locations to find its way to where it needs to go. So all of this culminated in a proof of concept on site. And after a naming competition, the robot was named QuendaBot. The Quenda is a native digging marsupial which lives in the bushland and gardens on campus, and hence the name was given. And this is the trial on the day, showing the robot installing the screws on site, well attended by media, got some coverage from 7 News and the like. So cognizant that we're getting close to the end of our time and wanting to leave some time for questions, I was just going to finish with some of the images that I think Neil has probably already gone through and explained in better detail than I could in terms of the architectural approach. So I will fly through those. I just wanted to finish by touching on a couple of things that we're doing in this space. We're at Oricon, we're members of MECLA and contributing to those discussions about embodied carbon. We have been actively involved in Timber 2032 forum hosted at UQ, advocating for the use of timber in the Olympics in Queensland. We're a principal partner at the Advanced Timber Hub, so working closely with Keith Cruz and the crew at University of Queensland to drive forward those research initiatives to push timber to become more and more mainstream, and hosting delegations, government delegations up to Queensland, where we have a very strong track record of having delivered timber buildings, to try and get more traction with government, which last week I was lucky enough to attend the opening of the Timberlink plant in Tarpeena in South Australia, which was attended by the SA Premier Peter Malinauskas, and I was lucky enough to have a few minutes with him to advocate further for the use of timber in more projects in my home state of South Australia. So on that note, Alistair, I think we'll leave it there.
Thanks, Ralph. That was fantastic. Thanks to both of you for your presentations. They're amazing. It really is just a spectacular building. And I think, as you mentioned, Ralph, you probably don't appreciate it sort of totally from the photos, which are stunning anyway. But yeah, I'm looking forward to getting over there myself. But yeah, certainly, as you encouraged, if people can get there and look at it, I just can't believe that learning environment. I was going to ask you about that, Neil. I think you mentioned just at the end of your presentation that you haven't done any formal studies about that biophilic benefit for the students, but yeah, you mentioned some of the feedback from the students and the teachers. Can you share just a couple of those sort of things that they've been saying about the structure to live and work in?
I think there's a lot of metrics that the university have got around kind of students' participation in the buildings beyond their formal class. It's a destination, which has probably got a little bit to do with the paucity of informal learning space on the campus in any case. Certainly the feedback they're getting from teachers and educators in terms of using the drop-in areas on the south end of the building and the teaching in the building. Obviously, often there's when you have to move into a large scale collaborative teaching space. Teachers often can struggle if they're not used to doing it, if they're used to working in tutorial rooms or lecture theatres, and they're being asked to change the way they teach. I think obviously the technology-enabled spaces, there's a lot of work that Murdoch's done to make it great environments for them to teach and therefore students to learn in. But, certainly they're all saying they really love teaching in the building. It just feels, light, bright, and, you don't have the sense of a lot of materials. I mean, that's the other thing I really like about it, is that because the timber is natural, ceilings are exposed, it feels like you're using a lot less overcladding material. You haven't got drop ceilings, you haven't got kind of plasterboard walls everywhere. There's almost no plasterboard in the building. So, I just think it actually does have a different feel, that you don't have to overclad everything. If it was raw concrete, you might think about that. But so I think, I can't, as I say, I can't give you perfect metrics, and, I haven't spoken to too many students about it, but certainly Murdoch are saying it's a much loved building.
Yeah, and all the open windows and the sort of looking out into nature really does give you that sort of true biophilic experience. Look, if people got questions, add them. We've got a little bit of time to do those. We've got a question here. Sorry, the one about bracing was answered. Thanks, Ralph. You picked that one up. But a question here about a lot of exposed timber surfaces, and assuming there was a lot of performance-based design to get the fire design signed off. Yeah, does either want to speak about that one from that fire perspective?
Look, I think that's correct, and you need a good fire engineer working with you who understands the way that timber behaves and the way that plays into the structural design. So, what might seem counterintuitive is that we actually use the timber to protect the metal elements of the connectors against fire, because we know the rate at which the timber will burn. And the other thing you have on your side is that, as I mentioned earlier, that timber design is usually serviceability driven. So the sizing of the timber is designed to make sure that we don't end up with a bouncy structure, which means that you have excess timber there that can continue to work for you in the fire condition. If the building's burning, people are more interested in getting out than whether the floor's bouncing under them. So we use that to our advantage. But yes, it is. It's a complex issue to work through, and when you're doing something that's not been done in state before, you do have to work closely with the authorities. And the feedback has been that this project has been a trailblazer, pardon the pun, for future projects in WA. Having been through the process on this project, now they are open to other projects, of which there are, I think the tallest timber tower in Australia is planned for Perth at the moment. So, basically we need to do more of these buildings so that they become more mainstream. So we're not talking about a niche, we're talking about something's the way we do things because it's the right way to do it for the planet.
Ralph, I don't know if you'd share these thoughts, but having worked on a large mass timber building here in Victoria as well, I think there's a lot to be said around an ECI process where the contractor is part of the thinking through how you get a elegant solution to fire engineering that doesn't require you to put large panels of fire check on the CLT, exposed CLT soffits, and as you say, obviously clearly a very sophisticated set of prototyping around the metal plates that are inside that create the moment action within the timber. I think ECI can't be underestimated in what how successful this building, because everybody's got to be on board and thinking really hard about you come up with a good solution, because the inverse of that is, especially around DNC, can be that you end up with some pretty clunky outcomes. if people aren't willing to engage across the board in the thinking.
Yeah, I agree, Neil. I think the other thing that can be challenging is that the requirements appear to vary state to state. And the other thing which, when you're coming into a fire engineered solution, other considerations like the access for the department come into discussions and the like. So, if it's a different situation, if we're building in a highly constrained CBD location in Melbourne, for example, where you can't get appliances adjacent to the structure, all that needs to come into the thinking and the appropriate responses. So yeah, it's not simple and straightforward, but engineers are smart people. We can work this stuff out.
Yeah, thanks, Ralph and Neil. I was going to point out that early contractor involvement, which really is one of the key to timber buildings, as we all know. And if it's a lesson taken away by the audience, is certainly to ensure that occurs. And also the point you made about hybrid construction, Ralph. I think as engineers or designers, it's all about using the right product in the right application. So it's not about a building's going to be all timber. Certainly that needs concrete and steel as well. And just to pick up on Matt's question there about earlier about termite compliance, I mean, certainly if you're in the ground where there's termites, concrete is a good solution, as is the pedestals that you've got there with the externally with the timber columns come down into, because again, termites need to, they need moist conditions, so they'll build mud tubes if they need to get from the ground to the timber, and we can see those and do the maintenance around them. We're out of time now, but that's been fantastic. So I really want to thank Neil and Ralph for such amazing presentations. It is such an incredible building and won countless awards. Neither of you spoke about that, but I don't know how many awards it's won, but it really is a credit to the whole design team. I just remind everyone that the webinars all are recorded. So if you'd like to go back and look at this again, or if you've enjoyed it and want to let your colleagues know about it, it'll be uploaded to the WoodSolutions website over the next week. Also, our webinar in 1 month's time on the 2nd of April at 11 a.m. is about CAD, CAM and BIM software for timber construction with Frank Davin and Crispin Elgley. So that'll be really interesting if you're interested in that area of software design. So I'd like to thank once again the speakers and thank you all for attending this month. Have a great rest of your week and thank you once again.